In this section, we'll be discussing the use of cubic spline for curve fitting purpose. If we have a plot containing 4 points, then we need to fit a curve through them. And we need to find the equation of this curve. So for cubic spline, the equation of the curve is f of x equal to ax cube plus bx square plus cx plus d. So in this particular curve we have three segments, and each segment has a different equation, namely a1 x square plus b1 x square plus c1 x plus d. This one has the equation a2 x cube plus b2 square plus c2 x plus d. And this curve, that is the third curve, this is curve 1, this curve 2, this curve 3. This curve has a3x cube plus b3x square plus c3x plus d3. And the given points here are x1, y1, x2, y2, x3, y3, and x4, y4. As it can be observed that we have three curves and 12 unknowns. The A's, the B's, C's, and D's. So we have altogether 12 unknowns. So we need 12 equations to find the values of these unknowns. So we'll be using some conditions for finding these unknowns. The first condition being that the function values must be equal at interior points. So we have two interior points, x2, y2 and x3, y3. The function value at these 2 points must be equal. So what we have here is, the first equation we have is a1 x2 cube plus b1 x2 square plus c1 x2 plus d1 is equal to y2. And the next one is a2 x2 cube plus b2 x2 square plus c2 x2 plus d2 is equal to y2. This is for the first interior point. For the second interior point, we again have two equations, a2 x3 cube plus b2 x3 square plus c2 x3 plus d2 is equal to y3. And the last one is a3 x3 cube plus b3 x3 square plus c3 x3 plus d3 equal to y3. So we have four equations from the first condition. The second condition is first and last function must pass through endpoints. So the endpoints are x1, y1 and x4, y4. Using this condition, we get two equations: a1 x1 cube plus b1 x1 square plus c1 x1 plus d1 is equal to y1, and the second being a3 x4 cube plus b3 x4 square plus c3 x4 plus d3 is equal to y4. So we get two equations from the second condition. The third condition is derivative at interior points must be equal. So the derivative of the function at interior points must be equal. So our function is ax cube plus bx square plus cx plus d. So its derivative would be 3a1 x2 square plus 2b1 x2 plus c1, which will be equal to 3a2 x2 square plus 2b2 x2 plus c2. This is for the first interior point, and for the second interior point we have 3a2 x3 square plus 2b2 x3 plus c2 is equal to 3a3 x3 square plus 2b3 x3 plus c3. The fourth condition is the second derivative at interior points must be equal. So taking the second derivative, we have 3a1 x2 plus 2b1 is equal to 6a2 x2 plus 2b2, can being 6a2 x3 plus 2b2 is equal to 6a3 x3 plus 2b3, and the last condition being the second derivative at endpoints are equal to 0. So at endpoints we have 6a1 x1 plus 2b1 equal to 0 and 6a3 x4 plus 2b3 is equal to 0. So in total we get 12 equations from all the conditions. We have 12 unknowns, so we can find the values of the unknown a, b, c and d. So this is how we use cubic spline for curve fitting.